Hi everybody! This is our video on multiplying radicals. Now if you notice, I've already written out all my perfect squares, which is something that you should do on your paper right now. It makes it easier to see when we simplify them. Now at this point, we've already done a lot of simplifying radicals. If that's something you feel like you need a review on, take a couple minutes and go back in your notes, because that's a skill we'll be using right now. Now here's how this video will work. I will go through one example at a time and walk you through one or two problems. You are to take notes on your sheet, and you can pause or rewind the video whenever you feel like you need to. After each example, I will tell you to pause the video and complete the practice problems that go along with it. So let's get started on our first example. You should be taking notes. Example 1, 3 radical 2 times radical 5. Now, the way we multiply them is we look at the numbers outside of the radicals and multiply those together, and then we look at the numbers inside of the radicals and multiply those together. So we have 3 times 1, which just gives us 3, and then we have radical 2 times radical 5, which just gives us radical 10. Now it's very important to always ask yourself whether or not the number inside of the radical can be simplified. In this case, radical 10 cannot be simplified because there is no other perfect square that goes into it evenly. So we have our answer right here. Let's try another one. This stays under example 1. We're going to do the same exact thing. We're going to look at the numbers outside of the radicals and multiply those together first. So we have 2 times 5, which gives us 10. And then we have radical 6 times radical 3, which gives us radical 18. And just like before, the most important question you have to ask yourself is, can the radical be simplified? Is there any perfect square that goes into it evenly? The answer is yes, and you want to choose the biggest one. The biggest perfect square that can go into 18 evenly is 9. So that's how we're going to separate that. We're going to keep our 10 out front, and we're going to simplify radical 18 by rewriting it as radical 9 times radical 2. Now, of course, we can simplify this more. We can bring down our 10. Now, what is radical 9? Radical 9 is just 3. So that's multiplied. Can't do anything with the radical 2. So we just leave that there, and now we can multiply our 10 times 3, which gives us 30. Keep the radical 2 there. And you're done with this example. Now is the time. Pause the video and complete the problems on your sheet. Alright, example 2. This time, instead of multiplying two monomials, we're multiplying a monomial times a binomial, because there's two terms in the parentheses. Now don't let the radicals scare you. We're just going to do this just like we do the distributive property in regular multiplication. So here's how we do it. We're going to take this radical 2 on the outside and multiply it by both of these numbers. First, we do radical 2 times radical 6, gives us radical 12, and then we're going to do radical 2 times 5, which just gives us 5 radical 2. What's the most important question you have to ask? Can it be simplified? Now I look at these two radicals, and I think the 12 can be simplified. So what is the biggest perfect square that goes into radical 12, it's 4. So we're going to rewrite that as radical 4 times radical 3. And then just finish writing the problem. Okay? And now you look at the radical 4 times radical 3, and you see that radical 4 is actually just 2. So that simplifies to 2 radical 3. Finish up the problem. 5 radical 2. The radicals are not identical, so we cannot combine them, and our answer is left as this. You may pause the video and complete the examples below. Okay, moving on to example 3. This time, we're multiplying two binomials. There's 2 terms in the first set of parentheses, and there's 2 terms in the second set of parentheses. We're going to do this exactly like we did distributing before, without radicals. Some of you like to call it the FOIL method. That means the first terms, the outer terms, the inner terms, and the last terms. Let's do it. So we're going to take our first terms, radical 3 times radical 2 gives us radical 6. And then we have radical 3 times 7, which just leaves us with 7 radical 3. Now we go to our inner terms. 5 times radical 2 is just 5 radical 2. And then 5 times 7, which we all know is 35. Now again, I always ask myself, can anything in the radicals be simplified? In this case, the answer is no. So we have our answer right here. Another problem for example 3. Again, it's multiplying 2 binomials. So let's take a look. We have radical 17 plus 4 times radical 17 minus 4. We're going to do the same thing. Let's look at the first terms. We have radical 17 times radical 17. We've done this before. That just equals plain old 17. Going to go to radical 17 times negative 4. Don't forget your negative because this is a minus sign. So that equals negative 4 radical 17. Now let's go on to this one. 4 times radical 17 is just 4 radical 17. It was positive this time. And now our last terms. We have 4 times negative 4. Positive times a negative equals a negative. And that's going to be negative 16. Now if we remember adding and subtracting radicals, we can combine like terms when the number inside of the radical is the same. If you look at these two, we've got 2 radicals in our answer, and they're both radical 17. They're both the same. So if we have this term, negative 4 radical 17, and positive 4 radical 17, we can add them together. Negative 4 radical 17 plus 4 radical 17 just cancels and equals 0. So now we're just left with 17 minus 16, and our answer is 1. Now that's interesting. There were radicals in the problem, but there's no radical in our answer. That's because there's a special word for these two binomials. They're called conjugates. Conjugates. So when you see a radical plus a number, and then the same radical minus that same number, you can automatically know in your mind that the radical is going to go away in your answer, and you're going to be left with a single number. So that's just something that's easy to remember and may help you with tricks in the future. Now you can pause the video and complete the problems on your sheet. Okay, example 4. This one we're combining a little bit of geometry. It says to find the area. Okay, so you have a rectangle here. You have the width and you have the length. Now what is area? Area is the space inside, if I were to color that in. And the formula for area, if you remember, is length times width. Oh look, it gives us our length and our width. So if we're multiplying them together, we're just going to plug it in. So our area is going to be our length, and we just said that our length is radical 11 minus 2 and our width is radical 11 plus 2. Remember, when the sets of parentheses are directly next to each other, it means multiplying. Now, what is special about these terms? If you remember from example 3, radical 11 minus 2 and radical 11 plus 2 are, what's our word? Conjugates. These two are conjugates, and what does that mean? That means that our answer is not going to have a radical in it. So let's try it and test that theory. Okay, we have radical 11 times radical 11, which just gives us 11. And we have radical 11 times 2, which just gives us 2 radical 11. And now we have negative 2 times radical 11, which is just minus 2 radical 11. And then we have negative 2 times positive 2, which gives us negative 4. Look at that. We have like terms because the numbers inside of the radical are identical. So our like terms are positive 2 radical 11 and negative 2 radical 11. If you take positive 2 radical 11 and subtract 2 radical 11, they both just cancel. And now we're left with 11 minus, can't forget some negative, minus 4. And our answer is going to be 7. Now before you pause the video to do your examples, I just want to remind you, the formula for an area of a triangle, because that's going to be one of your problems. The area of a triangle is 1/2 times the base times the height. It's just a little hint to help you with your problems. Okay, you can pause the video and complete the rest of your problems. Great job!